Hello everyone. So in this video we will be talking about the sentiment analysis. But we will not be talking about the sentiment analysis for the text. We will be talking about the sentiment analysis for the audio. Okay. But why do we need this? So in our previous videos we were talking about the voice bots. That is the human talking to a bot. Okay. Now there is a difference when human talks to human versus bot talks to human. There are two things that we are considering in this video. First is when human talks to humans, they can detect whether they are talking to a male or a female, right? But bot cannot do this. Second, humans can detect the emotions of the other side person, whether they are happy or sad. But as a bot, they cannot detect it. What they have is the text, but they don't have the emotion, right? So in this video, we are trying to detect these two things, whether the person we are talking to, the person the bot is talking to is male or a female, or what's their emotion. Now, obviously, these are the approximations and these can be tuned to, work better, but this can be the good starting point. Okay. So now let's first quickly see the demo and then we'll see how we are doing it. So I'll just play two audios file that I have.
Hello. Yes, tell me please. Yes.
So this is the male audio and it's a neutral tone, right? And I have one female sample also.
ओके एक्चुअली अभी एक ऑफर चल रहा है
And this is also neutral tone for a female. Okay, now we run our code of the. Okay, so it's run now. So as you can see, the first one is detected gender as male and emotion as neutral, and for the second one it's detect emotion as a happy or a pleasant, and the gender is the female, right? So gender is correct, emotion is also correct, right? And I don't have currently the sad or angry tones. You can test it and then obviously give me the feedback, and then I can also improve this code if it feels not working correctly. Okay, now let's just, so it's basically a rule based thing. What I'm doing is I'm detecting two things, the pitch and the RMS. The root means square, that is the loudness of the audio, and basis these I've created the rules which detects these two things. So I'll first show you the rules and then we can see the code. Okay, so first we'll talk about the gender, simple thing. So for a male, the average pitch is roughly around 85 to 155 hertz, and you can consider average as 120 hertz. And for a female, the pitch is generally higher, as you must be aware. So the pitch for females is roughly around range from 165 hertz to 255 hertz. Okay, so these are the simple rules for the gender. Now for emotion, it's slightly, it's a bit complicated. So if the voice is loud, that means the volume is high and the pitch is high, that means you are angry. If the volume is high, pitch is steady, you are happy. If both are low, then you are sad, and if both are medium, you are neutral, you are normal, right? So these are the rules that I've created, and these are the values I have just researched a bit and I've created, and you can play around with these values if you see these values are getting some issues. Okay, and okay, so let's move on to code now. Right, so yeah, so this is the main function, analyze motion. Okay, so what it does, it's first load the audio file. It detects the sample rate. Okay, now this y is passed to this. I've used the PYIN library. This is the probabilistic YIN library. There's one more library, pip track, which was used earlier, but it mixes noises and harmonics that we generally speak, and it diminish the quality of the result. So that's why this library is much better as compared to the pip track. That's why I've used this. Okay, so what I've done is I've passed this y and I've created two limits for it. Okay, so these C2 and C5 are nothing but the musical tones, the standard tones of piano, right? So C2 roughly is values around 65 hertz, and this C5 is roughly around 500 hertz. So as a human, we generally speak between 80 to 200, 300. So I have created a broad range that if anything beyond that, it will remove, to remove the any noise. Okay, so this is the F0 is the fundamental energy, fundamental matrix, and these are some other parameters. Okay, now there is also silence when we speak. So these silence can mess with the average of this. So that's why I've removed the silence and created the F naught clean, and then I've get the average page, which is the mean and nothing else. Then we talk about loudness also, which is the RMS. So I've get the RMS from the Librosa library that we've used, and we just get the min to get the average value. Now we have both our pitch and the volume, right? And as you can see, these are the simple tools that I've already created, and that's it. If you feel anything is wrong in this, please put in the comments. I would be happy to update it. And if you need any other help, if you need video on any other topic, please please ping in the comments. And if you like this video, please share, subscribe to this channel. Thank you guys. Thank you everyone.